Okay, welcome back to this Excel course. We're in the data chapter with the first video on text manipulation. So there's quite a few challenges which are hard to accomplish with text, and they come up time and time again in Excel challenges and competitions. So we're going to go through those common problems one by one, and I'm going to show you how to solve them. So most of these are taken from real challenges, and the first one is going to be all about identifying types of character. So a perfect challenge for that is this question here. So we have a bunch of puns, and each letter is worth its alphabet value, so A is worth 1, B is worth 2, but capitals are worth double the amount of points, and symbols and spaces are worth nothing. So let's just talk about first of all how to distinguish between capital letters and lowercase letters and symbols first of all. So if I have an uppercase and a lowercase a here, and I say equals this, it's going to tell me a true, that those are the same thing. However, we want to know if they are exactly the same. So there's a formula for that called exact, and that's going to kind of underpin the method we will do here. So if we say exact, it says false, they're not exact. If I change that to a capital A, now they are. So we're going to use this exact formula as kind of a trick to distinguish between capitals, non-capitals, and punctuation or symbols. So we also have the upper and lower formula. So if I say upper of these, it will give us the uppercase version. And if I say equals lower of these, it will give us the lowercase version. So you'll notice for symbols, the uppercase and the lowercase is the same. So that gives us a good way to determine if something is a symbol straight away. So let's type symbol, capital, lowercase. And we want to determine if these things are true. So we can say exact this. If that's true, it means we have a symbol. So that you can see that's only true for the symbols. For capital, we can say exact of the upper is the letter we already have. So if the upper version of it is the same as what it is itself, then we know it's capital. You'll notice that symbols come out true again, but that's fine. We would use this column as a first check, then this column as a second check, and then lowercase we can say exact this and the lower version of it. So we know if something is lowercase. So you can see these two are lowercase here, and that is true. So now that we know how to determine this for individual letters, how can we apply that to an entire string? Well, we need another trick here, which is probably the most fundamental common trick you need to know to solve Excel eSports cases, and that is splitting something down into its component parts, into its component letters. So let's grab a list here of just some numbers. So what we can do is use the mid formula here to say mid of this text, and let's lock that. And we can say our start number is this, and the number of characters we want is 1. So that's going to pull out the first character, and then the second character, third character, fourth character, and so on. Now the good thing about the mid formula is that this actually works with an array. So we can pull an array down there, you'll see we get spill error until we delete everything else, and we get out all of those. And another good thing is that instead of listing numbers here, we can now use the sequence formula. So let's do equals sequence of 20, and let's pull this down to match our array formula length. So now we start to pull down a lot more letters. So obviously we need to know how big this sequence is going to be, and it's going to be the length of however long that is. So let's say sequence of the length of our string. And now we get all the letters out. And because this all works with arrays, we can change this part of the formula to just be this sequence part here. So let's cut that and paste it there. And now we have all of the letters split down in a single formula. And we can change this to be whatever we like, and it will split it down into its component letters. So that is a little formula trick you kind of need to know as a fundamental. And with this information, we now have the tools to solve a level 4 in a real example eSports case. So we know how to get the letters for all of these, we know how to determine if they're capitals or lowercase, and our values are going to be aligned with the alphabet. So let's just write the alphabet out. So you could do that manually, but since this is a tutorial series, let's show you how to spell an alphabet dynamically. So each letter actually has a value underneath it. So you can use code or also Unicode, and we'll come back to this later, but we can say code of A, and it will tell us that it's 65. You can also do car to go the other way. So if I said equals car character of 65, that's going to give us A. So what we can do, we can say a sequence of 26. We know there's 26 letters in the alphabet, and we're going to start at 65, and then we can say equals character of all this stuff, and we get an alphabet spilled. So again, we can move this into our formula, and that is how to spill the alphabet in one simple formula. So now let's solve this whole question to get to the value of 455. Let's check if they are uppercase letters, and we're going to put this into one formula now, equals exact upper of this, and this works in arrays. And then we just highlight that again. So we're saying, is the upper of that exactly the same as what it already is? So we get a true for capitals and a false for lowercase. Let's get out our values here. So that's going to be a sequence of 26. Then let's look up the worth of the letter. So we can say x look up this in here. And again, we can use all of these things with arrays. And if it's not there, i.e. it's a symbol, we're going to put 0. So that is the letter's base value. If it's a capital, we need to times it by 2. So we can say if this is true, and again, we'll do it as an array, then do 2 times that x lookup. Otherwise, do that x lookup by itself. And the sum of all of these values equals sum of that should come to 455, which is the answer to this question. So that question is a very good example in terms of understanding how to capture what's capital, what's not, what's a symbol, how to split letters down, and how to assign values to things. Now task 2, we're going to expand on that a little bit, and this is from another real case. We had a list of orders, and these are the possible codes. So cheeseburger is CB, for example. And we need to find out how many items got ordered and what the price of the orders are. So let's recap our way to split things down into letters, but do it all in a single cell now. So we want the mid of this, and our start number is actually going to be a sequence of the length of that thing, and the number of characters we want is 1. So now we get individual letters. However, in this case, we want things split into 2s, and there may be other scenarios where you want things split into 3s, 4s, 5s, and so on. So how do we do that? Well, instead of taking one letter, we could take 2 letters. However, this is going to give us overlap, so it's going to give us BB, and then it's going to give us BS, because we're moving along this sequence one at a time. Now, just for explanation purposes, let's spell this out a bit more fully. Sequence of the length of this, and then we're saying mid of this by this 2 characters. We're starting at position 1 and pulling out 2 characters, then position 2 and pulling out 2 characters, so we are getting kind of overlap here. And sometimes you actually want that, but in this case we do not. So how do we get out every 2 characters without this overlap? Well, sequence has a handy argument for what steps you want to take. So we actually want to take steps of 2. And now we get a sequence that says 1, 3, 5, 7, 9, and so on. So now we get what we want, but we have all these blanks there. Because we're taking out letters into 2s, what we actually want to do is the length of the word divided by 2, and now everything lines up correctly. So let's now adapt our original formula. So we actually want the length of it over 2, and we want our sequence to go in steps of 2. And at that point, you see we pull out all of our orders correctly. We can then do something like XLOOKUP all of those, because XLOOKUP works on arrays, to here, and pull the price out, whatever else we want, and we get the price. We can then sum it up to get the total order. So it's $55 for that order. So that should essentially be all the things you need to know about splitting things down into groups with or without overlap. Now there is one other way to do this, which is a bit more modern. So regex is now in Excel, so we can take text and then decide what pattern we want. And there's a specific pattern, and that is just a dot. So if we say dot, that's going to give us the first letter. You can then put a comma 1 to say I want all matches as part of the regextract formula, and that will give you all matches of 1. But you can also pull out groups of 2 with a double dot, groups of 3 with 3 dots, and so on and so on. So this is sometimes an easier way. However, you don't have the option for overlap there. There may be a regex option for overlap, but I don't know it. Regex is a whole nother topic in itself. But we will be coming back to regex at the end of this video for some harder examples. Okay, task 3. Now this is from the same case, and it's kind of finding the orders where the text isn't exactly the same. So we have this, can I get 2 fries, a juice box, a cheeseburger, 3 sodas. So we want to find out what our order is, and we have the word soda here, but sodas here, and this can be quite a tricky challenge. Now my preferred approach is to use the search formula. So if I say search for cheeseburger in this text, I'm going to get, okay, a 35. If I search for bacon burger, however, I'm going to get an error because bacon burger doesn't exist here. Now this only works because all of these words are contained in every iteration of this. So it's either going to say cheeseburger or the plural cheeseburgers. And because this word is shorter, we can use the search formula. We can actually spell it as an array to see if the item is there or not. We can then use isNumber to pull out where it's true or false. And I can do something like if isNumber, give me this, otherwise give me blank. And then we get all of the items in their code form that are ordered. And then I think the real question in this example wanted us to concatenate them together. There was some more complexities with the number, like 2 fries, but that search trick is very useful, and I use that quite a lot. Okay, now a different topic. This is going to be counting occurrences of a letter. So the question is, how many S's for socks appear in this string? This is again from an eSports competition about laundry piles. So this was piles of laundry in a string. Where do you find the first sock? How many socks there are? All of those type of questions. So for this one, we use a common trick. So we'll say substitute this string for what we are looking for. So let's say we're looking for the number of socks, and replace our new text as blank. So now we get that string again, but without all the socks in it. So if we compare the lengths of these two strings, so we say length of this and the length of the top one, well, the top one will be longer because it's got all S's in. And the difference between these numbers is 15, so we know there would be 15 socks. So let's do this in a single formula. We want to say length of our original string minus the length of substitute our original string for the item we're looking for, which is this sock. Give us a blank back instead. And that should be it. So we get 15 socks. And now if we just lock these this text string, we can drag this down to find all instances of these items. So we now know how many of everything is in the laundry pile. Now another good thing about this trick is it will work just fine on arrays. So instead of just looking for socks there, we can pull that entire thing down and we spill them all like so. And now that we know how to do that, we can count occurrences of kind of anything. So we could count occurrences of SS, for example, so where 2 shoes appear next to each other, or any other string we like. We can also now answer questions like how many vowels are in this text string. So we could just spill out all the vowels, A, E, I, O, U, and we could do exactly the same trick that we did here on the vowels and sum this together to get how many vowels or consonants or symbols or anything else we like are within a text string. Now a similar problem is frequency. So rather than counting how many of something are in a specific string, let's say we wanted to count how many times each of the names here appear. Now we don't have a nice table like this to tell us all the names in a single string, but let's make one. So we can say to of this, but let's do it with a unique in front. So now we have every name only once. So there's a couple of ways to do this. So I could say count if this is my range, and these are my people, and then I have how many times they appear. So that's one way to do kind of a frequency table. A better way that works on almost everything is to do a group by. So it's quite a new formula, but it's essentially a pivot table. So we can say group by the to-col of all of this, and the values is exactly the same thing, to-col all of this. And our function is we can use count A or rows. I'll use rows in this case, and that is all we need. And then we get exactly what we had before, but in a dynamic way. And the good thing about group by is that we have an argument to order it. So if I say comma, 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 this is for the totals, my sort order, I can say -2. And what that means is sort the second column in descending order. If I had a +2, it would sort the second column smallest to biggest, but we want it the other way around, biggest to smallest. And now we can see, okay, Theodore here appears 3 times more than any other person. A common question is what is the most common item in this list? And this will allow you to do it. If the list here was only numbers, you can use a native Excel formula called mode. So if I did mode mult of these, this just tells me what the common number is, and the most common number here is 1. So when you're working with only numbers, this can be a much quicker shortcut to do that. Okay, next up, let's talk about ciphers. A lot of people's favorite cases, so this is shifting letters along the alphabet. So let's say A wanted to become B, B wanted to become C, and so on. So how do we do this? Well, let's do an example with capitals and non-capitals as well. So the trick to this one is to pull out the code, as I showed you earlier, of these things. Now, lowercase letters, A starts at 97, uppercase A starts at 65. So just to highlight some of this code character stuff a bit more. I'm going to get a sequence of 10,000, which is obviously huge. And then I'm going to say equals character. I'm actually going to say unichar because it covers a wider range of things. You get lots of symbols as well. The unicharacter of this, what is that? So this is all the symbols that line up with these code numbers. So obviously we've said capital A starts at 65 already. When you get to 90, you get into some brackets and symbols, and then we get the lowercase alphabet again. There's a big gap after that, and then you start to get into different language letters, and this will go down into many different kind of symbols here. And if you're new to this, you may not have seen these before, but you get things like emojis, music symbols, braille, all kinds of stuff. So let's talk about how to get A to go to B, B to go to C, and so on. Well, all we'd do is we'd take all of our codes and plus 1 to them. So that would give us the next letters, and then we would convert back with the character formula, and we would get that, and that will work for uppercase and lowercase. However, what would happen if we had a Z here? So let's take a Z. Well, Z needs to go back to A, and now it doesn't because we're going over that limit. So for uppercase characters, we need anything that's over 90 to cycle back to 65. So we can use the mod formula for that. So let's do a sequence of 30. So let's say A was 1 here. We would like to translate these to go to 26 and then back again. So what you can do is you can say mod this 26, and what you'll see is as soon as we hit 26, we cycle back round. However, we have a problem. The mod formula is basically giving us the remainder when divided by something. So the remainder when this number is divided by 26. So no 26 go into these numbers, so the remainder is that number. But when we get to 26, one lot of 26 goes into it and there is 0 remainder. So what we actually need to do is plus 1 to this whole thing. And now, instead of starting at 0, we start at 1. That's great. However, our first number starts at 2, and that's really annoying. So we actually need to minus 1 off inside the mod here. And what you see is now we do get a 1 to 26 and a cycle back round. Let's now apply that to our logic here. So we have one more problem here, and that's that our A is not starting at 1, it's starting at 65. So we need to actually minus 65 off, do the whole thing mod 26, and then we need to add back on the 65 at the end. So now that we know how that works, let's try to do that with this whole thing here. Now, of course, we need to split it down into letters, and this is why I said at the start that splitting things down into letters is so fundamental. So we need mid of this, sequence of the length of this, and give me every individual one character. Let's try and do this all in a single formula. So we now want the code of this. So we get the codes, we're in uppercase, so we know we have the 65 as our kind of anchor number. We need to plus our shift, so our shift is minus 17. So now we get all of these. However, we need to do that mod of that minus our 65. It's mod 26, and we're going to plus our 65 back at the end. So now we get all our new numbers, and we should convert those back into characters. So we wrap the whole thing in char, and we get number value, and our last step is to concatenate back together. So this is a cipher with a shift of 17 for the word number value. And now that we have that logic down, I mean, this is quite a complex thing to do if you're new to this, but once you've done it a few times, it becomes easier, and a lot of us have kind of built this methodology into lambdas. So I actually have something called shift text of this, and my shift is this, and it will just do all those steps kind of automatically, but all that's underneath the lambda is this thing, basically. And because we now have this in a single cell, this came from a real case, so I just want to show you some of these other words here. We could apply that whole thing to any of these formulas here, and we have kind of a cipher, a secret way to communicate in Excel. Now there's a lot more I could talk about in this video, but I'm only going to talk about one more thing, and that is extracting patterns. So the question is, extract all the numbers and letters from this string. Now in this first case, this is probably the easiest example you'll get because you have delimiters to nicely separate it. So we can say text split this on, first of all, the dashes, and that's going to split everything on that dash. And then we can say we want to also split on a semicolon. What we see is that spills us out all of the letters and numbers nicely. Now a harder example, I've removed all the delimiters. And let's say I want to pull all of the numbers out of this string. So there's a couple of ways to do this. So the first I'm going to do is to split on a sequence of 10 starting at 0. So that gives me all of the digits 0 to 9. So the good thing about text split, text before, text after is they work when you split on arrays as well. So if I say text split this on a sequence of 10 starting at 0, what you'll see is we get out all of the letters. So it's kind of split this on all of the numbers. Now once we've got this, we get a lot of individual gaps, so we want to get rid of them really. So there is an argument in text split to say ignore empty, so we want to use that argument to ignore the empties, and now we get only the letters out. And we can use exactly the same trick again, so instead of splitting down on individual digits, we can split down on all of these things. So we can say text split our string on all of these things, and again we want to ignore empty. And you see we get out all of the numbers. So that's a way to get out all of numbers and letters. Another way is to use regex. So again, a more modern formula, but this is a very easy way. You can click your text and our pattern, so in regex, if I was to type our pattern is D, it will pull out a literal D. But there are a number of special like use case characters in regex, and one of those is D standing for digit. So to enable that mode, you need to put a backslash before it. So backslash D is saying instead of looking for a D now, we're looking for this special character class, which is the class of digits. So if I was to do that, it's going to pull out any single digit. So the first one is a 1, that's correct. I could then put a 1 after the return mode to return all matches, and we get all individual digits out. However, we want all groups of 4 digits. So the other special syntax in regex is the plus symbol, and the plus means any number of. So after that D, I actually want a plus to say any number of digits, and then we get exactly the same thing. So 2 ways to pull out digits there. The good thing about regex is it's a lot more flexible. So I could, for example, say, I can see that first number plate is ES and then a number of digits. So if I wanted to pull out S and a number of digits, I could type that in literally, and it will pull out all instances. So the first one is ES19, so we capture that, and there's also another one in here. If I was just wanting to pull out the ES, I could put the literal ES there, and I can pull out like individual things from anywhere I like. So that's the benefit of regex, and I'm going to show you one more complex example. So let's say I want to pull out all instances of X, or X with a hash after from this string. So this is a perfect use case for regex. So we're going to pull out the pattern is going to be any literal X. Let's start with that. Our return mode is 1. We want all matches. So we pull out a number of X's, but we want all instances of X or X with a hash after. Now if we pull X hash, then we only get 2 of them out. So we know there's 5 X's, but 2 of them are going to have hashes in them. So how do we pull out all of them? Well, there's also syntax for an optional character, and that is the question mark. So another special character in regex, we want to say we want X and then an optional hash. So we type X hash question mark, and that question mark means that the last character was optional. So it can either be there or not. And when I do that, you see we pull out exactly all instances of X or X with a hash after. Now, there's still a lot for me to learn in regex, but it's, as you can see, this is very powerful. One of the most powerful tools, I would say, for pulling specific data patterns out of strings of text. So that's it for this video. There was a lot crammed in there, so don't worry if it takes some time to digest. Next time we'll have a video on numbers, so I'll see you then.